Okay, so now at this point, what we need to do is we want to look at driving another type of output, another type of common thing, which is going to be a servo motor. And let's talk about the servo motor first, and then we'll talk about the code for it, and then you'll actually put the servo motor connected up to your Arduino. So the first thing is these servo motors are from Parallax, and servo motors are they're DC motors that have some built-in sensors in them that kind of track what's going on. It's all abstracted from the user in these servo motors, so we just send it a control signal and power and ground, and we can tell it to move counterclockwise or clockwise. These are continuous servo motors, meaning that they can spin all the way around in a circle. So they can basically go in a circle forever, and they're really good for driving wheels and stuff like that. Some servo motors are not continuous, so they'll only move, like, for example, 0 to 90 degrees, and you essentially tell it, go to 30 degrees, and it'll go there and stop, and then go to 40 degrees, and it'll go there and stop. The BOE Shield actually has 4 connectors right here that are used to drive servos, and they're on pins 10, 11, 12, and 13. Okay, and so they're going to be up here. And in addition, what's really great about this is that the Arduino has a servo library that provides these built-in functions to control the motors. Now we're going to start off, we'll connect them to 12 and 13, and let's leave our LEDs connected. And the reason we're going to do that is because we're going to be sending this fast control signal to the servos, and it won't turn the LED all the way on or all the way off. It'll kind of be dim, but it's an indicator that we're actually sending something to the servos. So we're actually going to kind of have 2 things connected to pin 12 and 13. Okay, one note on pin 13 is that when it boots up, when the Arduino boots up, it'll actually pulse pin 13, and that's fine for what we're doing right now. But once you actually try to build a system that has to work, from startup, we'll probably want to move our servo over to like pin 11 or pin 10, something that doesn't pulse on startup. But if you see these things pulsing on startup, that's what's going on. Okay. The Arduino servo library is included by using a pound include, and then the syntax is servo.h with a capital S, and you have to put this at the beginning of your program. Then what you do is you use a keyword servo, and then you give an instance name for each motor that you have. So if you have 2 motors, you need to do 2 servo instances. If you have 4 motors, you have to do 4 of them. And this servo left is a user-defined name, so I just made that up. Servo right is another thing I made up. You can make up your own names. But the way that you can think about it is that that instance of the motor is going to be where you send these commands to. So you have to declare these instances after the include statement, but before you actually get into your begin loop. So those things have to be right there. Okay. Then there's 2 other commands that are interesting. One is attach and one is detach. And as soon as you attach the servo, what's going to happen is you tell it which pin the servo is on, and at that moment then you can send information to that pin, and you'll send it in a particular format, which we'll see in a second. The syntax for it is servo left, so that would be our instance name, and then dot attach, and then you give it the pin number. Detach is after you've been driving the servo for a while, you can actually detach it. And the reason you would ever detach is because once you start sending a signal to the servo, it'll stay going to the servo until you tell it not to. So you'll see that we send signals to tell the servo go counterclockwise, go clockwise, or stay still. And sometimes when you're having it stay still, you don't want that signal being sent. You're just wasting energy by sending that signal to tell the motor to do nothing. So if you keep it attached, you have to send that signal continuously. So sometimes you'll do a detach and actually stop sending that signal, and then the motor will just not spin just because you're not doing anything to it. For most of what we're going to do, we're just going to keep it attached and tell it to just sit there actively. Okay, how do you control the servo? The way that you do it is you send what's called a pulse width modulated signal. Now, a pulse width modulated signal is a repetitive series of pulses, and these pulses have a width to them, and the width of the pulse itself is the control signal. So for example, if it's a certain width, it might tell the servos don't move. If it's wider, it might cause it to turn a certain way. If it's narrower, it might cause it to turn a certain way. So that's how we're going to actually do this control. Okay, in this situation, the servo library actually handles sending these pulses for us once we do this command called write microseconds. And it'll send these pulses every 20 milliseconds, which is 20,000 microseconds. But what's kind of neat about it is that all you need to do, the argument for this, is you just tell it to send a particular pulse width in microseconds. So I specify right here as the argument the number of microseconds that I want the pulse to be high. Now, how do I use this? Well, it turns out that these servos, if you send them a 1500 microsecond high time, that is the stay still state. So that's where you tell them don't move. And the syntax for it is servo left, that is the instance user defined, I made that up, and then the command is .write microseconds with a capital M, and you simply give it the high time. If you want to send it to the other servo, you give it the other instance name, which in this case is servo write, and then you do write microseconds, and then 1500. Now, when you first pull these out of the box, what's going to happen is that they need to be calibrated. Okay, so calibrated means you're sending it a signal that needs to be, it means to sit still, but out of the box they might spin a little bit, or they might vibrate a little bit. And so you have to actually adjust them to get them into a state where they won't spin. And we do it by, there's a little Phillips head screwdriver that comes with the kit, and you stick it in the side of the motor and you can adjust it, and we'll do that here in the next activity. Okay, to get it to go clockwise, you send it a a smaller pulse, and the smallest you can send it is 1300 microseconds, and that represents spinning clockwise as fast as possible. And all you do is you just do the write microseconds 1300, write microseconds 1300, and of course you can send anything in between 1300 and 1500 and it'll just spin slower, so you can kind of ramp it up all the way to full speed or ramp it down, but 1300 is as fast as it'll go. And then counterclockwise, you send a fatter pulse, and the maximum is 1700. So you just send that to it, and this would cause it to turn counterclockwise as fast as it possibly can go. Okay, and again, you can go in between. Okay, so now what we're going to do right now is let's go ahead and fire up a new sketch, and let's write the stay still program. Okay, so I'm going to go ahead and do a new sketch, and we're not going to test this yet because we don't have the servos connected, so that'll be the next activity. But what we can do is just look at how we use the syntax of the servo library and figure out how to actually use it. Okay, so what I'm going to do is I'm going to go ahead, and the first thing I'm going to do in my sketch is I'm going to save it. So I'm going to go File, Save. And let's go ahead and put this on our desktop where we've been working, and under Arduino, and we'll call it Chapter 2, Activity 3, and then we'll call it Servo Stay Still. Okay? Alright. First thing we need to do is we need to go in and we need to include the servo library. So I'm going to do a pound include. And then I'll go ahead and do servo with a capital S.h. I've now included my servo. Okay, that's the servo library is now in there, and it gives me access to all the functions, the built-in functions. Okay, now I'm going to do a keyword servo, and notice how it turns orange. That's a keyword. And what we're going to do is I'm going to create these names of my motors. So I'm going to call the left one servo left, and I'm going to call, then I'll do another servo function again and say servo right. And I have declared, so these are declaring instances of the motors. And from here on out, I can use these names when I drive, when I actually send commands to it. Okay, now let's come in down here, and of course I'm always going to be doing stuff with the serial monitor, so I always want to set up my serial monitor. So I'm going to do a serial.begin and 9600, and then I'll do a serial.print, and I'll call this activity 3, and we'll say servo stay still. Okay, and that tells me that I'm running the right program, so I know that. And then I'm ready to actually start putting some code in here. So the first thing I need to do is do the attach function. So the way that I do that is I go servo left, that's my name of the motor that I'm doing, that I'm going to do something with, and I do keyword attach, and then I give it the pin number. So this is going to be on pin 13. So it's basically, you're saying, hey, servo left is now active and it's on pin 13, and that's where I'm going to send information. I'm going to do the exact same thing with servo, the servo right, which is on pin 12. Okay, so I just do a servo right. Okay, and this is basically attach servos and tell pin numbers they are on. Okay, life is good. Okay, so now I'm sitting here and my servos are attached and they're ready to start going, and I would like to, I'm going to come down here. Actually, I don't even need to do that. Let's do it right here. I'm going to go ahead and send out the command to tell the servos to stay still. The way that I do that is like this. I go servo left, I put my instance name, and then I go at period, and I go right microseconds. And then I give it how many microseconds I want to send, and it's 1500. That's the amount of time that the pulse needs to be high in order to stay still. Okay? And let's go ahead and do, you do a lot of copy and paste when you're doing this stuff, so Control Z and Control V. So we'll do a servo right, and I'm going to send that thing. So now I'm sitting here, and I want to do one more message to myself to just know that I'm where I'm at in my code. So I'm going to do serial print. I'm going to say telling servos to stop. Okay? And that is essentially the entire program. Okay, so we don't have anything else. We're just going to send that signal. What's neat about it is that these things right here will send, and those signals will continue to send even as you move to other code statements. So for example, if I put another print statement and said just sent signal, it won't like call this function and sit indefinitely in here. It just turns on the signal, the pulse width modulated signal, and leaves it running forever, and then it goes on to the next statement. This one turns on the servo right pulse width modulated signal and leaves it forever, and then it moves to this. And that's kind of neat because you don't have to sit and continually call this to generate the pulses. You just call it once and it's off and running. Okay, so let's verify this and make sure that it's okay and doesn't have any syntax errors. So we go ahead and verify it. And no problem. Okay, so at this point, why don't you do that? So go ahead and write the program that I just did, and we're not going to use it right now because we got to attach our servos and battery pack, but we want this program because the first thing we're going to do is actually download it and calibrate our motors. So go ahead and pause the video and write that program.